In this video, we are looking at solving equations, and more specifically, how to apply these 6 questions to every equation that we will come across in Algebra 1. So we're going to start out with our first example, being an example of solving a simple two-step equation, the equation being 16 equals 4 minus m. So we start off with the first question here, which is, do I need to clear fractions? Well, we have no fractions, so I do not need to do anything with this step. Next, do I need to simplify one or both sides? So I'm going to look at both sides of the equal sign and make sure that they have been simplified. 16 is as simple as it can get, and 4 and m are not like terms, so we can't do any combining here, so this side is also simplified. Now we look at the next one, which is, are there variables on both sides of the equal sign? There's only a variable on one side, so that's good. I don't have to worry about that. Then it says, do I need to add or subtract? So what we're looking for here is to add or subtract the constant term that is on the same side with the variable. In this case, we have a 4, so we are going to subtract that 4 because this is a plus 4. So we subtract 4 from this side, and to maintain our equality, we're going to subtract 4 from the other side. 16 minus 4 is 12. These make a 0 pair, so we put a z through those to represent that they have zeroed out. And then we bring down what's left, which is the negative m. So now we've done what we can to get down to just the variable term. So now I ask myself, do I need to multiply or divide? So I'm going to either multiply or divide by the coefficient of the variable. Well, the coefficient here is negative 1. So I'm going to divide both sides by negative 1. 12 divided by negative 1 is negative 12. And negative 1 divided by negative 1 is positive 1, so we're left with positive 1m. So this is our example for simple two-step equations. Our next example, example 2, will be a two-step equation with a variable. I'm sorry, not with a variable, but with a fraction. So that example is going to be v over 4 minus 5 equals negative 7. So first thing we're going to ask ourselves is, do we need to clear any fractions? Well, yes, we do. We have this fraction here. This is our fraction bar. We have a denominator of 4. So what we're going to do is take the entire equation and multiply it by that denominator. And this is going to be a distribution to absolutely everything inside the equation. So I'm going to take the 4, multiply it by v over 4, take the 4, multiply it by negative 5, take the 4, multiply it by negative 7. Well, when I do that, it's kind of like a very long distribution because we're taking everything on both sides and multiplying it by this 4. This 4 and this 4 are going to cancel out, leaving a v. 4 times negative 5 is negative 20, and 4 times negative 7 is negative 28. So here we have cleared our fractions. After we've cleared our fractions, we need to see if we need to take either side and simplify it, and neither side can be simplified because these are not like terms. The variable is already only on one side, so now I can either add or subtract to get rid of that 20. Well, since this 20 is being added, the inverse operation is addition, so I'm going to add 20 to both sides, and these two numbers should equal each other to maintain our equality. And then what's going to happen is these guys are going to make a 0 pair, so they zero out, leaving v equals, and then we have negative 28 plus 20, which is negative 8. In our next example, example 3, we're going to look at a case where we are going to need to simplify one or both sides. So in this one, our example is x plus 4 minus 4x, and that is all equal to negative 20 plus 3. We still start at the top here, and we're going to look at whether or not we need to clear fractions, and since there are no fractions in this equation, we do not need to clear any. But next it says, do I need to simplify one or both sides of the equal sign? So I'm going to look on this side and notice that yes, I do have some like terms over here that can be combined. X and negative 4x are like terms. On the other side of the equal sign, we also have negative 20 and positive 3, which are like terms on that side. So what we're going to do now is simply combine the like terms. 1x minus 4x is negative 3x, and then we bring down the plus 4. On this side, negative 20 plus 3 is negative 17. Now this side can't have any more simplification done to it. It is as low as it can go. And this side is also as low as it can go as far as combining and the number of terms that we have. So now we look to see if we have variables on both sides. We actually only have a variable on the left-hand side, so we're going to solve for this variable. To solve for this variable, we look at the next question that we ask ourselves is, can I add or subtract to get rid of one of these terms? And yes, I can. This is addition, so I can use the inverse operation of subtraction, and then I can zero out on the left-hand side so that all I'm left with is the negative 3x, which is our constant term, our variable term. The constant term had canceled out, or zeroed out. Then we have on the right-hand side negative 17 minus 4, which gives us negative 21. Now we are not finished because this variable is not by itself. There's still that coefficient of negative 3. So can I divide or multiply to get rid of that? And yes, I can. If they're multiplying, then I can divide. So I'm going to divide both sides by exactly what is in front of the variable, which in this case is a negative 3. The negative 3's cancel out, leaving the x. And negative 21 divided by negative 3 is positive 7. So this has been 3 examples of solving some simple equations. First off, we had a simple 2-step equation. Then we had a 2-step equation with a fraction where we had to multiply everything by the denominator to get rid of those fractions. And then the last one was a case where we had to simplify both sides of the equal sign before we could find our solution. So this will be on page 21 of your composition book, and we will have more videos with more examples coming up.